welcome to Chapter 2, Lesson 1. We're going to start solving equations in Chapter 2. So this entire chapter is about our ability to actually figure out the answers to variables. So we're going to start doing some introductory algebra. So our objective for this lesson is to solve equations that have rational coefficients, and we're also going to solve equations using multiplicative inverses. The standards we're going to be addressing is 8th grade equivalent expression standard 7, 7a, and 7b. Let's go ahead, start our vocab, get into our key concept, and look at our first example. For our vocab in this lesson, we have two vocab words. The first vocab word is multiplicative inverse. Multiplicative inverse are two numbers with a product of 1. So that means when we take two numbers and we multiply them together and we get 1, that means they have to be multiplicative inverses of each other. An example of that is if I took 2/3 times 3 over 2, well, 2 times 3, that's 6. 3 times 2, that's 6. When I take a 6 divided by 6, I get 1. So what that means is 2/3 and 3 over 2 are multiplicative inverses. Really, it happens anytime we have a fraction. If we take a fraction and multiply it by the same fraction flipped, or its inverse, we're always going to get the number 1. Because it's always going to end up with a situation where the top and the bottom are always the same, and we get 1 as the answer. The coefficient is the number that's in front of a variable. It's a number that multiplies to the variable. So if I wrote the number 2a, 2 is the coefficient because it's the number in front of the variable that's multiplying to the variable. This really means 2 times a. The 2 is the coefficient because it's next to the variable and it's right in front. So let's go ahead, look at our key concept, start our lessons, and solve some problems. We're talking about multiplicative inverse because we're going to be using multiplicative inverses to solve problems. So it's very important to understand the idea of taking a fraction and multiplying by the same fraction flip to get the answer of 1. So multiplicative inverse is the product of a number and its inverse, which equals 1. We just covered that on vocab. So the way it works using numbers is if I had 7 over 8 times 8 over 7, well, 7 times 8, that's 56. 8 times 7, that's 56. And if I take top divided by bottom, I get 1. So if you're looking at it, you see one fraction, you see the same fraction flipped. When you multiply them, they equal 1. And it doesn't matter if that number is positives or negatives, it still works the same ways. A negative times a negative, that's a positive. 3 times 2, that would be 6. 2 times 3, that's 6. 6 divided by 6 is 1. So no matter what the fraction is, if we multiply by the same fraction flipped, we're always going to get 1. Using algebra, it looks like this. If I have a divided by b times b divided by a, the answer is going to get 1, no matter what those numbers are. The only rule is a and b cannot be 0 because we're not technically allowed to divide by nothing. Okay? So we cannot divide by 0. It's not anything that we can do, so that's the one thing we can't do. Any number times the same numbers flipped is always going to equal 1 as long as we can write them as fractions. Let's start our first example and see how multiplicative inverse can help us solve some problems. For our first example, we're going to be solving 3/4 of c equals 18. So we're going to take 3/4 times it by c, and c is a number we don't know. 3/4 is the coefficient of c, because one of our vocab words is coefficient. 3/4 is the number that's right next to the variable, it's in front, which means it's multiplying by the variable. So we need to know 3/4 of what number is 18. So we have to figure out this number. And that's what algebra is all about. So we're getting into the idea of introduction to algebra. Algebra's idea is to figure out what a variable is equal to. A variable is an unknown number. So we don't know what c is. Our job is to get c alone. So what we're going to do is we're going to write down 3/4 c equals 18. So we're rewriting the problem. We don't want to know what 3/4 of c is. We want to know what 1c is. So our goal is to change this c from 3/4 to the number 1. Well, if we're changing it to one letter c, we want this number to be a 1, not 3/4. Multiplicative inverse says that we can change that number to a 1 if we multiply by the same fraction, just flipped upside down. So we're going to multiply the left side by the same fraction flipped upside down. Now, in mathematics, one of the biggest rules that you have to understand is, if there's an equal sign, if you do something to the left side of the equal sign, you have to do the same thing to the right side of the equal sign. So, we want to change this to one letter C, not 3/4 C. So we're going to multiply it by 4/3, which is the multiplicative inverse. And if we do that to one side, we have to do it to the other side. So we multiplied by 4/3 on the left, 4/3 on the right. Now looking at this, this says 4 times 3, that's 12. 3 times 4, that's 12. So really this is 12 divided by 12, which equals one letter C. Alright, I got 1C. I know what 1C is going to equal. It's going to equal whatever I get on the right side. So now, to do this, I'm going to actually kind of show you a trick about how to work with fractions. But first, we're going to actually use a calculator, and then I'll show you my trick. So, I'm going to use my calculator here. Oh, wrong calculator. That one doesn't work. Use this calculator here. So, I have 18. We're going to multiply straight across, so 18 times 4, that equals 72. And 1 times 3, that's 3. So my answer is going to be 72 divided by 3. So I'm going to type in my calculator 72 divided by 3. And I know that the letter C should equal 24. So my answer is one letter C is 24. Okay. So I could have got this answer a little bit quicker without taking 18 and putting it over 1 and making it a fraction. I know that my answer is 24 that I'm looking for. So what happens is, whenever you multiply by a fraction, you're multiplying by the top number and dividing by the bottom number kind of at the same time. Now, to me, if this number right here will divide by the number on bottom, I like to make the number small and then multiply it by the top. You have the option of taking 18 times 4, that's 72. 72 divided by 3, that's 24. So that's kind of how we can get that number. I like to do it kind of in reverse order. I take the number that's here, I divide it by the bottom to make it small. 18 divided by 3, that's 6. 6 times 4, that's 24. Since I have multiplication and division happening at the same time, you get the same answer. You don't have to do this method of taking the whole number, dividing by the bottom, and then multiplying by the top, or taking the whole number times in the top, divided by the bottom. You can do what we did originally and just make them both fractions and multiply straight across and get your answer the same way. If you're trying to do it without a calculator, this is just one method you could do. You could take the whole number, divide by the bottom, multiply by the top, the whole number times the top, divide by the bottom, or you can make them both fractions and go straight across, get this fraction here, and divide it, and you'll still get the same answer. So these are just options that you can do without using a calculator to solve problems. So we just figured out that one letter C is 24. It didn't just tell us that we're done after we figured out our answer. It says, we're going to solve this problem. So we solved it. Now we have to check our solution. So we have to actually make sure that 24 is the right answer. So what we're going to do is, using a calculator, we're going to write 3 divided by 4 to make it a fraction. And we're going to put it inside parentheses. I'm going to make my parentheses a little smaller. So we're going to put that inside parentheses so we can actually use it in a calculator. Tells our calculator we need to do this first because 3 divided by 4 is happening first. We're going to times that by 24. And if this answer is correct, our answer should equal 18. If it doesn't equal 18, then the number that we got right here would be wrong. So I'm going to use parentheses and type this in my calculator. So I got parentheses 3 divided by 4 times 24, and in fact I do get 18. 18 is the right answer. So this means that we know that 24 is the right number that C could be. We solved it mathematically by multiplying by the inverse, and then we went and did it to the other side, because if you do something one, have to do to the other. Let's keep going and solve some more problems. This time it's going to go a little bit faster because we understand what an inverse is. An inverse means that we're multiplying by the same fraction flip. So rule of thumb to follow, is anytime we have a number next to a variable that's a fraction, to get rid of it, we multiply by the same fraction flipped on both sides. Multiplicative inverse. In example 2, we're going to be solving the equation 2/3 of A equals 12. So 2/3 times something equals 12. We're going to check our solution. So first step, we're going to write our equation. Now, reminder, we don't want 2/3 of the A. We want to have just one letter A. So our goal in algebra is always to get the letter A by itself or only have one of those. So we want to change 2/3 to the number 1. We learned that a multiplicative inverse is when we multiply by the same fraction flipped, we get the answer of 1. So all we're going to do, draw a line through our equal sign, and we're going to multiply 2/3 by 3/2 because that's the inverse. And if we do that to one side, we have to do it to the other. 3 times 2, that's 6. 2 times 3, that's 6. And 6 divided by 6 equals 1. So now I have one letter A equals, now I'm going to do my method. I'm going to take 12 divided by 2, that's 6. 6 times 3, that's 18. So one letter A equals 18. Now I could check it by doing the fraction method. 12 times 3, that's 36. 1 times 2, that's 2. And 36 divided by 2 is also 18. So I see that the answer I got should be correct. One letter A should equal 18. So in reality, that means that the letter A, or the variable A, is equal to 18 in this problem. We're going to check it by typing it in our calculator. Reminder, when we type it in our calculator to check our solution, we want to type 2 divided by 3 times it by 18 and see if we get 12. Or we can use my method, 2 over 3 times 18 and see if it equals 12. I'm going to go ahead and use my method, then I'm going to check it in the calculator. 18 divided by 3, that's 6. 6 times 2, that's 12. I got the number 12. Now I could do the other method and multiply by the top, then divide by the bottom. 18 times 2, that's 36. 36 divided by 3, that's 12. So no matter which way I do it, I'm getting 12 as my answer. Now I'm just going to use a calculator real quick to triple check my answer, not double check because I've already double checked. 2 divided by 3 inside parentheses times 18, and in fact I get 12 again. So I checked it 3 different times, 3 different methods, and every time I checked it, I got 12. I know that 18 is absolutely the right answer. All we had to do to get rid of a fraction next to a variable, we multiply by its inverse on one side, do it on the other, we get our answer, as long as it's the only thing that we have to do. In example 3, we're going to look at mixed numbers. We have one mixed number times the variable x equals another mixed number. Not only are we going to solve it, but we're going to check our answer to make sure that our answer is correct. So when looking at this, we aren't working with fractions, we're working with mixed numbers. So we probably should change this to an improper fraction. So we need to change mixed numbers to improper. Now, hopefully some of you remember how to do this from 5th grade, 6th grade, 7th grade. Now we're in 8th grade. We've been doing it for a while, but if you don't remember, all that means is we take the whole number and we times the denominator. We take that answer, we add the numerator, and we keep the denominator the same. So, to change a mixed number to an improper, all we got to do is multiply by the denominator, add the numerator, keep the denominator the same. So the way it looks is by doing this, we take the whole number 1, we times it by 2. So 1 times 2, that's 2. we're going to add the top. 2 plus 1, that's 3. So the mixed number 1.5 is really 3 over 2x, and it's going to equal, and I'm going to change the other mixed number into improper as well, 16 times 2, that's 32. 32 plus 1, that's 33. And we keep the denominator the same. So whenever you change a mixed number to to an improper fraction, all we got to do is take the whole number times the denominator, add the numerator, so that's how we get 3. 1 times 2, that's 2. 2 plus 1, that's 3. That's how we get 3. Keep the denominator the same. Do the same thing to your other mixed number, because if you change one number, you should probably change all the others just to make sure that they're fractions too. When working with fractions, it's easier to have everything in the same type of style. So we have 3 halves of x equals 32 halves. And we're going to try to figure out what that answer is. Now, we don't want to know what 3 halves of x is. We want to know what 1x is. So we're going to use our multiplicative inverse the same way that we've done previously to solve this problem. So we're going to get this letter x by itself, or we're going to get one letter x by multiplying by the same fraction flipped. If you do that to one side of the equal sign, you're going to go ahead and do that to the other side. Make sure that you make the fraction exactly the same as the one that you did over here. It has to be the same fraction, just flipped upside down. Now, 2 times 3, that's 6. 3 times 2, that's 6. And we know that 6 divided by 6 equals one letter x, which is exactly what we wanted. We wanted one letter x. 33 times 2, that's 66. 2 times 3, that's 6. So we know that 1x is equal to 66 divided by 6. That means x should equal 66 divided by 6. That's 11. X should equal 11. Now, we're not done with this answer. We actually got to check our solution. Luckily, I know that 1.5 means that it's 1.5. And I'm going to take 1.5 times 11 to check to see if I get 16.5. So, 1.5 times 11. And in fact, I get 16.5. Now, I could take 11 and times it. I'm going to multiply it over on this side. Times it by 3 halves, because that's what we're kind of doing here. So 3 halves times 11. 11 times 3, that's 33. And 33 divided by 2 is 16.5. So we'd have 33 over 2, which is what we got right here when we change that to a mixed number. Or when we change this to improper from a mixed number, that's what we got was 33 over 2. And 11 times 3 is 33 over 2. So we would know that this is, in fact, 16.5. So 11 is correct. We're going to go ahead and do another problem just like this one, dealing with mixed numbers, changing them to improper, and then solving that problem. In example 4, we're almost done. We've only got about maybe 4 more problems to do, maybe 2 more problems. We'll see how it goes. I'll just double check before I start opening my mouth because I'm crazy. All right, so cool. In example 4, we're halfway through this lesson. And so far, it's going pretty quick, pretty easy. We're just multiplying by inverses to get rid of those numbers. So in example 4, we're kind of doing the same thing as we did in a previous problem. We're solving 2 1/4 of some number equals 18. So again, we don't want 2 1/4. We want to know what one letter b is equal to, or one variable b. So we're going to actually have to get rid of that 2 1/4. But in order to get rid of a mixed number next to a variable, or the coefficient of 2 1/4 being next to a variable, we're going to actually have to change that mixed number to an improper fraction. So I still kept this rule here. Whenever we have mixed numbers, let's go ahead and change them to an improper fraction. Reminder, if you change one thing to a fraction, you should try to change everything to fractions to make it a little easier to work with. So we have 2 1/4, and we're going to change that to an improper fraction. So 2 times 4, that's 8. 8 plus 1, that's 9. So really, we have 9/4 b equals 18. And I'm going to go ahead and make that a fraction. A reminder, if you want to put any number in the world as a fraction, all you got to do is put it over 1. So I don't want to know what 9/4 of b is. I want to know what 1b is. So we're going to use the rule about multiplicative inverse. So I'm actually going to erase this 2 1/4 because I've already changed that to an improper fraction. If I want to get rid of a fraction next to a variable, we multiply by its inverse. So we're going to multiply by 4/9. And if we do that on one side, we do that on the other side. 4 times 9, that's 36. 9 times 4, that's 36. So 36 divided by 36 equals 1 letter B. So now we got 1 letter B by itself. And so I'm going to kind of do the same thing, but I really don't know what 18 times 4 is off the top of my head. So I'm going to use my other method. I'm going to take 18 divided by 9, that's 2. 2 times 4, that's 8. So 1 letter B should equal 8. That's what my B should equal. Now, I could check that. I'm going to actually go ahead and check it using a calculator to check what 18 times 4 is. 18 times 4, that's 72. And 1 times 9, that's 9. So if I take 72 divided by 9, I do get 8. So this right here equals 8. So without using the calculator, I was able to get the number 8. Made it a little quicker and easier to do in my head than just multiplying straight across. Now, I probably could have figured out what 18 times 4 is without a calculator. I just made it quicker without using a calculator to divide by the bottom, multiply by the top of this fraction, because I know that 18 was really a whole number to start with. So 1b is equal to 8. We're going to check to see if this solution is correct. So we said that our answer is going to be 18 over 1. Okay. So we're taking 9/4 times 8. So really, our problem is we're taking 9/4 and timesing it by 8, and it should equal 18. And that's because 9/4 is the mixed number 2 1/4. Well, 9 times 8 is 72. And if I take 72 divided by 4, I should get 18. And if I do get 18, I got the right answer. If I don't get 18, I don't get the right answer. So 72 divided by 4, my calculator does in fact say 18, and that's how I know I got the right answer. So 8 is the answer to this problem. That's the answer I'm looking for. The letter B is 8. We checked our solution. It does give us a true answer. We know we're right. Let's keep going. In example 5, we're going to actually kind of switch gears. We're no longer going to work with fractions. We're going to switch to decimals. So we need to be able to read this sentence. So it says solve 3 1500ths, or 3.15, equals 0 4500ths, or 0.45, ends, or variable n. Check our solution. So we're actually solving this problem. 3.15 is equal to 0.45 of something. We need to figure out what that something is. So our job is to figure out the variable n. So I'm going to rewrite our problem. We have 3.15 equals 0.45n. Our job is to get this letter n alone. And again, we want it to be 1n. So what we should remember maybe is in mathematics, if we want something to become 1, all we got to do is divide it by itself. So if my decimal is 0.45, we can divide it by itself because a number next to a variable is multiplying. A coefficient multiplies to the variable. So to get rid of something in mathematics, we do the opposite. The opposite of multiplying is dividing. So what we would do is we would divide by 0.45. And if we do that to one side, we need to do that to the other side. Any number divided by itself in mathematics equals 1. 1 divided by 1. 1. 2 divided by 2. 1. 3 divided by 3. 1. 4 divided by 4. 1. Any number divided by itself is always 1. So 0.45 divided by 0.45 is 1n equals. Now in this case, I'm going to go ahead and use a calculator to solve this problem. So 3.15 divided by 0.45, and I get 7. So my letter n should equal, or my variable n should equal 7. Because 1 times anything is that same number. 1 times n, still n. So n equals 7. Now it says check your solution. So I'm going to go ahead and type in my calculator 0.45 times 7. And if I am correct, then the answer should be 3.15. So 0.45 times 7. And in fact, I do get 3.15. That means 7 is the correct answer. I checked my solution. It's right. Let's keep going. In example 6, we're going to solve another one that involves decimals. We're going to solve 10.8 equals 0.9n. Again, it doesn't matter what side the variable's on. We're still going to solve it the same way. Our job is to get one letter n or one variable n. So we're going to get that n kind of by itself. That's what algebra is all about, getting our variable by itself. So in this problem, we have 10.8 equals 0.9n. Again, we want to change this 0.9 to the number 1. We know in mathematics, if we want something to equal 1, all we got to do is divide it by itself. And if we do that on one side, we do that to the other. Notice that we do not touch the variable n. We're trying to keep the letter n there. Don't touch it. Only take the number, divide by number. And if you do that on one side, do it on the other. 0.9 divided by 0.9 gives me 1. So I have one variable n equals 10.8 divided by 0.9. I'm going to go ahead and type that in the calculator. 10.8 divided by 0.9, I get 12. So my variable n is equal to 12, and that's my solution to this problem. Now it says check our answer. So to check it, we're going to type in our calculator 0.9 times 12, and if we are correct, our answer should be 10.8. 0.9 times 12, we get 10.8. We know that 12 is 100% right. You don't need me to check it. You can check it yourself. Use a calculator to double check your work. Let's do 2 more problems, call it a day. For our last 2 examples, we're going to be looking at some word problems, and our job is to define a variable and then to actually write down an equation and solve that equation for the variable. So here is an example of the problem. It says a Kayla's softball team won 75% or 18 of its games. So 75% is 18 of its games. 75%, which is 18 of its games. Our job is to define a variable. So we need to figure out what piece of information is missing. Then write and solve an equation to determine the number of games the team played. So I know that 75% is 18 of its games. But it says that we need to determine the number of games the team played. So the games the team played is the variable I don't know. I know that they won 75%, which is 18 of their games, but I don't know how many games they played total. So what we need to do is we need to set a variable equal to the number of games played. So n equals the number of games played. This is what we're trying to figure out. We need to figure out how many games they played. That's what the question tells us that we have to figure out. We do know that they played 75, which is 18. So we know that 75%, which is the decimal 0.75, of however many games they played, 75% times however many games they played is going to equal 18. Now, this looks like the problems we were solving earlier. We need to figure out the letter n. So we need that n to not be 75% of that n to equal 18. We need it to be 1. So we're going to go ahead and divide that by 0.75. And if we do that on one side, we do that on the other. 0.75 divided by 0.5 gives me 1. So 1 variable n is equal to 18 divided by 0.75, 24. So if a team won 75% of their games, and 75% of their games is 18, then they played 24 games. 24 games, 18, 75%. If you win 18 out of 24, that's 75%. One more problem, and we're done for the day. Alright, for our final example, where you're looking at one last word problem, this one we're going to use Monte. Monte has some fabric that he will use to make curtains. 45%, so we have 45%, which is 6 yards, because it says 45% or 6 yards of the fabric is green. So 45% represents 6 yards. We need to define a variable, then write and solve an equation to determine how many yards of fabric he has altogether. So our question is, how many yards of fabric? So I'm going to write Y for yards he has. That's what we're trying to figure out. We're trying to figure out how many yards of fabric he has. So I'm going to use Y as my variable. I'm defining the variable. My variable is going to be Y, and it's going to represent how many yards of fabric he has. Now it says we're going to write and solve an equation. So we know that 45% of however many yards he has, so 45% is the decimal 0.45. Of the yards he has. The word of means times, so 45% times the yards he has is equal to 6 yards. So this is how I came up with my equation. 45% of the yards he has is equal to 6 yards. We're going to change that letter Y to the number 1. So we're going to divide it by 0.45 on one side, divide it by 0.45 on the other. This cancels out, and we get Y equals, and I'm going to use a calculator, 6 divided by 0.45, that equals 13.3 repeating, which I know is 13 1/3 yards. So I know that Monte has 13 1/3 yards of fabric. That's my answer to this problem. You guys did awesome today. Make sure you like this video, smash that notification bell, and if you guys have not subscribed yet, make sure you subscribe so you get all these notifications of when these videos are posted. And I will see you tomorrow.